Welcome to aminacademy.com. In optimization of multivariable function in economics, let us do some solving problem. First, let us do one problem regarding partial elasticities. Look at this example. If Q equal to 700 minus 2P plus 0.02Y, where P equal to 25 and Y equal to 5000, find the price elasticity of demand and the income elasticities of demand. The first one, the price elasticity, that is sigma D equal dou Q by dou P of P by Q, where dou Q by dou P, here with respect to P, this dou Q by dou P is 700 goes and minus 2 and Q is given as 700 minus 2P is 0.02Y. Which is equal 700 minus 2 into 25, P is 25 and 102 to 5000, because Y is 5000. Let's calculate this. Gives 750. Then sigma D equal dou Q by dou Y into P Y over Q, not P over Q, which is equal minus 2 into 25 by, which equals minus 0.067 by calculation it gives. Next one, sigma Y. Sigma Y, which means that the income elasticities of demand, which is equal dou Q by dou Y, Y over Q, which is equal 0.02 5000 over 750, which is equal 0.133. Next question. Look at this question. Given the profit function y equal 160x minus 3x2 minus 2xy minus y squared plus 120y minus 18 for the firm producing two goods x and y. Now, first one, maximize profit. Second, test the second condition. And third is evaluate the function of the critical values x and y, x bar and y bar. look at here for this. Given the profit function is given and this first pi x. Pi x means differentiation of this function y function with respect to x, which gives 160x. Differentiation is 160 and 3x squared is minus 6x. Here 2 minus 2xy differentiation partial derivative with respect to x is minus 2y. Y that equal 0 and pi y. Pi y is here 0, here 0, here minus 2x, because minus 2xy derivative with respect to y is minus 2x minus 2y, that is y square derivative is minus 2y plus 120. By solving this, while solving these equations, we get x bar equal minus 6 and y bar equal 20. Then we can substitute these values, critical values, with y xx minus 6. X and y value, if you substitute, now we have to find first the second partial. Let us take second partials. We have pi xx, that is derivative of this function with respect to x is minus 6, because this will not come because this is in terms of y. Next is pi yy. This y function with respect to y is minus is minus this is minus 4y. Yy is minus 4y differentiation is minus 4. Then cross differentials pi x by xy. Yeah, pi xy differentiation with respect to y is minus 2. Then by substituting, third one you have to find, just the second condition is tested. Third is evaluate the function at the critical values of x and y0. We have to substitute these values in original function, that is q's. Now from this we have to check y xx, y yy is greater than cos pi xy. Thus pi will check the conditions, that is pi xx is 6 minus 6 into 5y is minus 4, which is greater than 5xy is minus 2 the square, which means 24 is of course greater than 4. So second test tested. Third is evaluate the function at the critical value of x bar y bar. Then by substitution of this function by all x and y critical values, we'll get this pi, that is third, pi is maximized, pi is maximized at x bar equal y bar equal to 20. Therefore pi value, substituting these values x bar y bar critical value, it gives 2782 by using these values and functions. Here x bar is x bar is 24. X bar is 20, y bar is 20. Now next question, what combination of good x and y should a firm produce to maximize the cost when the joint cost function is c equals 6x squared plus 10y squared minus xy plus 30, and the firm has production quota of x plus y equal 34. Estimate the effects on cost if the production quota is reduced by 1 unit. Look at here. This constraint optimization in economics discussion. Now the firm have new function by setting the combination constraint equal 0 by constraint function c equal 6x squared plus 10y squared minus xy plus 30 plus constraint is lambda. This constraint function is 34 minus x minus y become 0. Then cx means partial derivative with respect to x equal 12x minus this y will become 0, here minus y because xy derivative is y, then that is 0, and minus y minus y minus lambda, because here lambda minus lambda x is minus lambda, this equals 0, and cy equal 20y because their differential is 20y plus 2 into 10y, here minus x and minus, here also minus lambda. Then third is c lambda. C lambda is minus 34 plus 34 minus lambda x, derivative is minus x minus y equals 0. With respect to lambda, this function will come, derivative of this function. Next, by solving simultaneously, we can get x bar equal 21, y bar equal 13, and lambda bar. The solution you are keeping x bar y bar lambda bar to 39. By using these values x, y, lambda and this function will get C. The cost function value is we are using x values, y values and lambda values we are getting by, I'm not showing the solution solving method, but you can do substitution. Then C equals 4093. The second order conditions are, the second order condition is already discussed, we can follow that. And what they are estimate the effect on cost if the production quota is reduced by 1 unit. Then effect on cost function reduced, that is lambda equal to 39. A decrease in constant of the constraint, that is production quota, will lead to a cost reduction. The cost reduction by approximately by 239. That means estimate the effect on cost if the production quota is reduced by 1 unit. It gives the lambda value of 239. Next question. A company's sales is have been found to depend on price P advertisement A and the number of field representatives R in maintains x equal this function. Find the change in sales associated with hiring another field representative and extra $1 of advertising. Then third one, a dollar of 0.1 reduction in price at P dollars, P equal $6 and R equal 49 and A equal to $8,100. This gives that here. For this we will calculate delta x, that is delta x equal to dou C by dou x, which gives into delta R, which is equal half into 12,000 minus 9,000 P, 900 P into A power half into R power half. Half into 12,000 minus 900 into 6 into 81, 1800 for half into 49, 9 into 1 or 90 for half, 49 for half. Already written here. which gives the value 42 by calculation it becomes 42 or 29. Then delta y. So rho c by dou y delta a now, delta x here, second part is delta x same with dou s by dou a, dou s by dou a into delta a half 12,000 minus 900 p of a for half or for half. By using these values, we get finally 2566 hour. That means look at here, all these 0.6 hour. By using these values given here. Next is delta R. Delta R equals dou S by dou P into delta P, which gives minus 900 A for half or for half dp. By substitution these values, minus 900 into 90 into 7 into dp, the change in price is 0.10, which gives approximately $56,700. So far we discussed about some solving problem regarding mathematical economics in maximizing or optimizing the function. We have done. Please subscribe our YouTube channel.